How can we search through an array? Often you might want to be able to check if an array contains a particular value, or you want to search to find where that value is. Let's have a look at how we can do that. Now, what we want to do is we want to check the value against all of the values in the list. So what do we do for each value? Well, in this case, we can check if the value is the one that we're after. And if it is, we can either return the value, its index, or that we found it. Let's have a look at doing that now inside our program. So here I have my program's code. Let's write a function that can tell me whether a name exists in a list. We could call it contains. I want to be passed the list of names and the name to search for. Is this name in that list of names? Or does this list of names contain that name? How do I check each one? Well, I could check each one by saying if the current element, we'll add the loop in a minute, equals the name that we're after. And if it does, then I can return true. I need to put that inside a loop. So I have my loop for int I equals 0. That's my initializer. While I is less than the number of elements in the array. Oop, I've forgotten to add that as a parameter. Int size. There we go. Is less than size. And, oops, I plus plus for my increment. What I do at the end of the loop. We can put all of that inside the loop as my body. Now, I do have to return false at the end of the loop here. Why do we do that? We return false at the end of the loop. Well, if we think about this here, if I put else return false, remember that return ends this function call. So we would check the first name. If the first name is not the one that we're after, we would say, oh, that's it. I can't be bothered checking the rest. I'm out of here. That's false. Whereas really what we want to do is we want to make sure that we loop through for each element, check each element against the name, return true, which means we don't continue if we find one that matches. But if we don't find any that matches, then we get to the end of the loop. And I know if I get here, the only way that was possible is that none of the names match the name that I was after. Let's put something down here to test that out. So I could say bool has Andrew. That's my variable name. And we can initialize that, or we could store a value in that, which is calling this contains function. Does names with that size contain the name Andrew? And if it has Andrew, then I will write out a line contains Andrew. There we go. Now, one thing I thought about, this is lowercase, so we probably want to make sure that we are matching lowercase names against lowercase. So here we could do 2 lowercase, and we'll match the same thing here, 2 lowercase, just in case the caller forgets to pass in their value in lowercase as well. We could optimize that a little by storing it, calculating it once for the name, but we'll leave it as that for the moment. Let's compile and run that. Let's put in Andrew, and then there we go. We get the total length, and it says that it contains Andrew. If I run it again, and we type in different names, we can see we don't get the contains Andrew. It didn't find that value. Now the key thing here with this contains function, we were wanting to know whether it existed or not. At this point, we actually have different things that we could return. We've already talked about why we return false at the end of the loop. Remember, the idea was you have to loop through all of them, checking each index to see if that's the one you're after. Only at the end do you know that it didn't contain it in any of the indexes. When we're searching for a value, we might be wanting the value or its position. We might also just want to know whether it exists or not. So in this case here, we're checking whether it exists. If I wanted the value, then I could return the value from the array itself, names at index I. Alternatively, I could just return an int and say where the value was, in which case I would say return I at this location here. You have to work out a default in each of those cases. So with the index, my suggestion would be to return something like -1 if you didn't find it at all. So -1 would indicate it doesn't exist in the array, whereas a 0 or higher value would indicate that is the position in the array where the value is stored. If you're returning the value itself, you need to have some meaningful default. What about things like minimum and maximum? These are a little bit more tricky. In these cases, you want to compare the elements against some temporary value, sort of like we did with sum, where we stored a temporary sum that we added to each time. In this case, you would compare the current value against that value. The secret here is to make sure that you use a minimum or maximum from the array itself. So start with one of the values from the array. Otherwise, you might potentially accidentally give the wrong value because the value you started with. So for example, if I was looking for the maximum in an array for an integer, and I started my maximum at 0, that might not be the right value. All of the values in the array might be negative, which would mean that 0 is higher than all of those values, but is not actually a value in the array. So always start with a value from the array. And check against that value for the maximum or minimum so far. So it's like the idea with the total, where we're doing the running total. Here we would be doing the running minimum or running maximum. Let's have a go at doing that with the shortest name. In this case, we can look for the shortest name in the list of names. You can then add these other functions, or you can add the index of function to determine whereabouts a name is in an array, and adjust print summary to print out the shortest name and the index of your name in the list of names. So our shortest name function needs to return the name itself. So we're going to return a string. It's called shortest name, and it's going to take, there we go, it's going to take the list of names and its size. All right. Now we'll just make an assumption that there are some names to start with. So we're going to create the current shortest name. I'll call it min because this is effectively a minimum function. We want the minimum to start off being the first element in the array, and we can return the minimum at the end. Okay, so now what we need to do is then loop for each element in the array. Now in this case, we can start at the second element because I've already got the first element as the current minimum. No need to check it against itself. We would then loop while I is less than size and increment I at the end of the loop. Inside the loop, what will we do? Well, we can check if the length of the name, so the length is the length of the current shortest name larger than the length of the current name. So the current name is names I, and we're after its length. So is the current shortest length name too big? Is it bigger than the length of this name in the array? If it is, missed I there. If it is, then we know that at this point, the minimum name is not what we've currently stored, but this value here. This value here has a shorter name than the current minimum. So at this index, this is the shortest name so far that we've encountered. Once we get to the end, we then can return that shortest name. Let's output that down here. So we can pass that into the function here. So right line, shortest name from my list of names which has this size. I compile that, oops, extra backslash there. I can then run it, and there we go. So we have a total length of 21, and the shortest name is Joe, which we can see is correct. If we have two names which are the same length, oops, I've just put in an empty name. We see that the shortest name is that empty name, which is correct because it had no characters in it. So if we had two names which are the same length, and then are all, or if they're all the same length in fact, then the shortest name in this case will be the first name that it encountered. Because we've told it only to update the name if it is larger than, if the current minimum is larger. If they're equal, then we keep the existing one. Okay. So that's how to calculate the shortest name, and you could use the same sort of logic to calculate any minimum. Have a go at finding the index of a name in the array, and then adjust print summary so that it prints out the details listed here.